iodized salt and common salt look completely identical. So how do you physically prove the invisible iodine is actually there? All you need is a slice of raw potato and a pinch of unverified salt. Sprinkle the salt directly onto the potato's exposed center, but waiting alone doesn't help. The salt dissolves, leaving the potato looking unchanged. To force a reveal, introduce a catalyst, exactly 2 drops of lemon juice. The acid helps the salt's iodine bind with the potato's natural starch, instantly turning the testing zone a vivid, dark blue. That blue color guarantees iodine. If it stays pale, it's just common salt. So what about that unverified batch of mystery salt sitting in your kitchen pantry right now? Run this exact test. If that potato turns blue, you know for sure you are getting genuine iodized salt.
The FSSAI water test exposes fake sugar. But how does a simple glass of water physically separate the real from the fake? Scammers often mix cheap chalk powder into sugar and jaggery to fraudulently increase the weight. To catch them, take a 10-gram spoonful of suspicious sugar and drop it into a clear glass of water. Before it hits the surface, the finely ground chalk perfectly mimics the sugar crystals, making the fake completely invisible. But watch what happens inside. Pure sugar molecules immediately break apart and blend into the liquid, a property called being highly soluble. The water is left perfectly transparent and clean. Chalk, however, is a totally different material. It simply cannot dissolve in water. Because it remains a solid powder, gravity forces the dense chalk particles to physically separate and sink. So what happens to that suspicious 10-gram spoonful from the very beginning of the test once everything finally settles? If a thick, milky white layer is left sitting at the very bottom of the glass, you've just caught the chalk.